In this module, we shall deal with the concept of session hijacking. Session management and security vulnerabilities are some of the most severe issues found in web applications now. Before we go more in depth into this issue, it is important to understand what a session is. Sessions deal with the concept of persistence of end-to-end connections between the server and the client maintained by exchanging data between them at regular intervals. It is mainly used to overcome the statelessness of HTTP. What I mean by the term statelessness is that HTTP does not keep a record of the state of the user activity on a server. So to ensure mechanisms for a contiguous time period for user activity, sessions hijacking deals with the process of capturing or discovering the session details by an attacker and utilizing the same to gain access to the corresponding user session. It mostly takes advantage of the fact that session verification takes place at the initial stages rather than at regular time periods. Now it becomes important for us to understand the subcategories of such attacks. Session hijacking can be classified in two categories, namely active hijacking and passive hijacking. In active session hijacking, the attacker tries to look out for an active session and uses various tools to take over the session by predicting the next sequence number in the TCP session exchange. In passive session hijacking, the attacker employs a sniffing on a network to find out user authentication details, such as user credentials and other information, in order to use that data to create a new session. The idea with both types of session hijacking is to grab some form of user data that can be utilized for sessions. Such data could range from user credentials to session cookie parameters. The success rate of session hijacking has diminished in recent times, with major applications on the internet as well as organization intranets employing various measures such as encapsulating HTTP over SSL in order to prevent cookie stealing via sniffing on the network. Cookie stealing is mainly done nowadays by injecting malicious JavaScript files in the web application, and when a client visits the server, the JavaScript code is loaded onto the browser and sends back the cookie details of the current user sessions active in the browser. Widely prevalent protection measures against such attacks has led session hijacking into a corner, but it is still one of the most dangerous attacks around depending upon the scope of damage it can cause. We shall now delve into an example of TCP session hijacking. In this slide, it is shown that two hosts A and B have an ongoing TCP session between them. Shown here also are the positions of the sending and receiving windows for the respective hosts. At the next sent packet, the sending window of host A and the receiving window of host B move forward by one position by following the sliding window mechanism. Now the attacker aligns its sending video with that of host A by finding out the sequence number of the TCP packet. It then sends a forced packet to the host B. Following the sliding window mechanism, the host B now moves its receiving window forward, thereby realigning its position according to the attacker's sending window, and in the meantime sends a response to host A. On receiving B's response, host A responds with a RST message, thereby cancelling out its own sending and receiving windows. Further into the connection, the attacker simulates the host A's sending window and the host B's receiving window, thereby getting a hold of the connection details. The simulated windows start transferring data within themselves, thereby maintaining the session, and the attacker sends forced packets to both end hosts to suppress them, and thereby maintaining the session on its own. It is shown here that host A's packets are sent to the simulated receiving window of host B, and B's packets are received by the simulated receiving window of A, while the attacker keeps suppressing the host. A common symptom of session hijacking would be to monitor the sequence numbers of the session packets, as there are bound to be discrepancies in their order careful regulation on packet ordering would lead to timely detection and mitigation of such threats. Now, session hijacking can be employed by a number of techniques depending upon the network scenarios. Some of the precursors to this process are man in the middle attacks, blind hijacking, session theft, which is via script injection in browser, DNS poisoning, which leads to redirection of legitimate users and capturing of the session details, which can be misused by the attacker. All of the aforementioned techniques have various subcategories based on the circumstances and parameters of web application and the network. It all depends on the session management features and the transmission security of the web application, for which security can be implemented via various means, one of them being SSL. Now, session hijacking is implied as a single phase attack, but it does consist of a series of steps which depends on the monitoring mechanisms and tools employed by the attacker. The phases of session hijacking are as such: tracking the session. In this phase, the attacker identifies an open session and predicts the sequence number of the next packet. The second is desynchronizing the connection. In this step, the hacker sends the valid user's system a TCP reset, which is RST, or finish, which is FIN packet, to cause them to close their session. The third is injecting the attacker's packet, wherein the hacker sends the server a TCP packet with the predicted sequence number and the server accepts it as a valid user's next packet. One of the most common scenarios encountered in this attack is a predictable sessions token attack. A predictable session token attack leads the attacker to find out patterns in consecutive session tokens and predict a few tokens which can be validated by the web application to create a genuine session. Now, it is important for us to differentiate between the concept of spoofing and session hijacking, which, although closely related, are different in nature. Spoofing refers to the process of an attacker finding out identity details of users and impersonating the said entity to gain access to the web application. Whereas in session hijacking, the attacker gets a token which refers to the user session, invariably a token assigned by the web application, which is independent of the identity details. As a proper example, imagine spoofing as a scenario where the attacker gets the login credentials of an user, and in session hijacking, he gets the session cookie of the user, which is valid only for one session. While we are on the subject of differentiation, it is also essential to understand the differences between a man in the middle and man in the browser attack. Man in the middle, which is MITM attack usually employs spoofing to intercept the traffic in between the client and the web application in order to find out session details. In a man in the browser, which is an MITB attack, the attackers injects JavaScript code into the client browser via the web application's vulnerabilities or redirection in order to get access to the browser-based information such as cookies, including session cookies, and use the information to conduct a session hijacking. Man in the browser attacks are harder to detect and require throughout inspection of the client browser and web application so as to mitigate damage for such an attack. Focusing on the preventive aspects of this topic, listed here are some of the countermeasures which can be employed to prevent session hijacking attacks. Encryption of the data traffics passed between the parties, in particular the sessions key, though ideally all traffic for the entire session. Second is using random generators for session keys. Thirdly, regenerating the session ID after a successful login. Fourth, changing the cookie values with each and every request. Fifth, conducting secondary checks for the users. Also, encouraging proper logout of users to dispose of the deprecated session data. The emphasis is on protection from the web application as well as the network level. Now, from the network perspective, the most effective is encryption such as IPsec, which is Internet Protocol Security, It has the ability to encrypt your IP packets based on a pre-shared key or with more complex systems like a public key infrastructure, which is PKI. This will also defend against many other attack vectors such as sniffing. The attacker may be able to passively monitor your connection, but they will not be able to read any data as it is all encrypted. There might be actions an attacker could take against an IPsec enabled network, depending on if they use IKE PSK or PKI to manage the encryption keys. But this would require an experienced hacker. Please note that IPsec is not a one-shot solution. It has its own share of flaws which can be exploited with the proper tools. Now IPsec is configured in mainly two modes, transport mode and tunnel mode. IPsec modes are associated with two core protocols, the authentication header, that is AH, and encapsulating security payload, that is ESP. Both of these protocols provide protection by adding to a datagram a header containing security information. The choice of mode does not affect the method by which each generates its header, but rather changes what specific parts of the IP datagram are protected and how the headers are arranged to accomplish this. This figure illustrates the details of transport modes of IPsec. As we can see, the encapsulation includes a header which contains the following: IP header, secondly IPsec header, the third is transport data, and the fourth is IPsec trailer. IP header deals with the routing details of the packet, while IPsec header contains the authentication header, which provides integrity authentication services to IPsec capable devices, so they can verify that messages are received intact from other devices. The main job of ESP is to provide the privacy we seek for IP datagrams by encrypting them. An encryption algorithm combines the data in the datagram with a key to transform it into an encrypted form. This is then repackaged using a special format that we will see shortly and transmitted to the destination, which decrypts it using the same algorithm. ESP also supports its own authentication scheme like that used in AH, or can be used in conjunction with AH. The tunnel mode in IPsec is different from the transport mode in the sense that it encapsulates and encrypts the IPv4 data instead of just encryption as in the transport mode. On the last slide, it is imperative to discuss about the components of the IPsec architecture. The protocols associated with it are ESP protocol, key management protocol, and AH protocol. On the bottom level, we have encryption algorithms, authentication algorithms, and domain of interpretation. That is all for the concept of session hijacking. Following this would be a demonstration to illustrate the same.
In this video, the concept of session hijacking shall be explained. In here, we shall use a tool called as Kane Enable. So right click on the tool, click on Run as Administrator, and the panel for Kane Enable will open. So the first thing that you should do here is you have to start the sniffer. So click on Stop Sniffer and press on OK on this message. Select the proper interface for your network and then click on OK. So in case if the sniffer is not activated, you have to activate the sniffer again. Go to the sniffer tab, go to the plus sign, and then from the options select all tests and press OK. So this tool shall scan the network for all the hosts which are there connected in the network. Here we have found 4 hosts. Now we shall select the tab which accounts for ARP poison routing. So just click on the empty panel and then click on plus. Here on the left hand side, select the gateway IP address, and on the right hand side, select the machines for which you want to employ sniffing. Once the machines are selected, just click on the yellow reactor button and the poisoning will start. Poisoning is basically used for redirection of traffic on the network. So on the victim machine, we shall try to open a Facebook account and try to hijack the session from that account. So basically, for hijacking the Facebook account or any other account, as a matter of fact, we have to find out the cookie which traverses through the network while the session is active. So for that, we have to use Wireshark. So open the browser and then open facebook.com in a new tab. So here I am opening the home page of Facebook, which includes the login page. So this is the login page of the website. It could be any other application also. So I'm trying to log into my account. Once we enter the password and then click on login, we are logged on to the account. Now there's a thing to note here. Facebook uses HTTPS by default. So the HTTP packets are encapsulated with encryption. So what we have to do is remove the HTTPS extension and then reload the page. So that will enable us to capture the HTTP packets and consequently the cookies. Now while the session is trying to open, we try to filter out the cookie packet from Wireshark. We type in the filter http.cookie contains DATR, where DATR is the parameter employed by the Facebook cookie. So here we get only 2 packets as now. So we tried to see whether this cookie is present in this packet or not. So following the steps as such, we extract the cookie details from this packet. Finding out the cookie is a difficult task, and in Firefox, if you want to use this particular cookie, we have to enable an extension which is known as Grease Monkey. Opening the home page here, and in Grease Monkey we have to install a JavaScript known as cookie injector, which shall enable us to write the cookie which we have extracted using Wireshark into the Firefox browser. So pasting the cookie, we can see that we have written the cookie in the browser. So we shall check whether this is the authentication cookie or not. We did not get any result using this cookie. So that means we have to find out the proper cookie for this account. So here we can see that we have got another packet in which there is the probable authentication cookie which we require. So using the same process, we write the cookie onto the browser and then reload the page. And here we can see that we have opened the account. So what we did was we tried to redirect the traffic on the network and find out the cookies which contains the sessions for this particular Facebook account. And you can see that the account is opened simultaneously in different machines. So this is what is known as session hijacking, in which we gather the cookies of the session from the network and use it for our own purposes.